Good morning. This video is to talk about how we are going to graph in the science classroom. Most of you guys are probably very familiar or have graphed in math class before. And for the most part, a lot of those skills are going to transfer. There are a few differences that need to change for a scientific classroom, which is why we're going to go over it right now. Now, you guys have done, should have done by this point, graphing pretest, which is just me seeing like how you can graph ahead of time. Based on that pretest, if I were there, usually in most years, I would I would basically look through all of them and be like, hey, you need this, hey, you don't. But since I'm not there, that's why we're going to show the video to everybody. Obviously, if you need to come back and watch this video at a later time, the link is going to be in the assignment, and you can skip all over that. Maybe you don't need obviously the stuff at the beginning or anything like that. But yeah, feel free, of course, to pause the video as we're doing it so that you can follow up with this. All right. So if you go to Google Classroom, you will see where it says graphing. I'm going to click that. So if you, well, I would do that on your Chromebook if you have that available. If not, maybe on your phone. Get that pulled up because I'm going to be flipping off of that and then sometimes into this right here, and you probably want to be able to track where you want to go on yours. I'd like you guys to write down notes for this. I encourage notes both because it's a good idea, as well as I will pretty regularly come out and check your graphing notes or some type of notes to give you guys points for what you're doing on the day. Okay, I'm never going to try to, like, as you're looking at this sheet, I'm never going to make you write down the entire sheet. I'm going to talk to you about how to make things a little bit simpler for yourself. But yeah, so for your notes today, as we're going through this, what you're going to do is you're going to write down the bolded word and also what comes next to it. None of these dots, we'll talk about all of these dots as we're going through. You can come back to this to reference them, this worksheet if necessary. But yeah, you just need to write down the the labels or the bolded words and what comes next to it. Okay, as well as I'll have you write down these shapes a little bit later on. And the last thing is, as we're going over these, we're going to do a practice one. You will need a piece of graphing paper and a ruler in order to do these graphs correctly. So hopefully you have all those things. If not, we can pause here and you can go get them real quick. Let's go over it. All right. So the purpose of a graph is to, in a science class, is directly connected with a lab. In a lab, we're measuring stuff that takes place in the real world, like we're measuring velocity or time or weight or mass or all these different things and comparing them to each other to try to figure out how the world works and what makes sense. So a lot of times this boils down to numbers and putting them in a way that can help us to understand what it is that's going on. The big difference between a science class and a math class is that math typically, because they're not as worried about exact data, are just going to give you numbers. They're going to make up some numbers, and oftentimes these numbers are perfect. Like, for example, on one line you might see 3, 6, 9, 12, 15. Or you'll notice each of those go up by 3 exactly every time. There's nothing wrong with this. They're trying to focus on something specifically that is not what we're trying to focus on. The problem is for science is that we typically don't get that perfect data because, as I said, the data comes out of a lab. So when you make measurements of distance or time, it usually doesn't go up by the same number every time, like 3, 6, 9. It usually goes 2.4, 3.7, 8.6 and bounces all over the place. And 2, what I just said, it has a lot of decimals and has a lot of numbers that aren't perfect or whole numbers. So we need to do some stuff slightly differently. Now this first section should probably be about the same, but let's talk about how to do it. So we're going to, like I said, we're going to use this data right down here. So the first thing I want you to do is, if you're still writing this down, take a break. Or if you haven't started writing down, that's fine. First thing we're going to do is we're going to start the beginning of our graph. But before we do that, I want to show you something really important about making the y-axis and the x-axis. And those are as follows. This can go, actually, this can go in your notes. This doesn't need to be on that graph yet. Okay, you can just, let's say we had 2 graphs, which we should use a ruler. I'll talk about that in a second. Okay, let's say we had two graphs, right? Kind of a big one here, okay, and I won't use the ruler for that, and a smaller one. Oftentimes, when people put graphs on a page, they'll use just this tiny section, like over here or over here. They'll try to fit a lot on the page, okay? Which is not a major problem with that, except for, well, this is what we're going to say. You see, if I use this tiny graph, and usually nobody's making them this tiny, but I'm doing this to serve a point. If I am supposed to put the dot right here, I'm supposed to put the dot right here, right there, and instead I miss, and I put it right down there. You'll notice on this tiny graph, that's a gigantic problem, okay? Even missing by a small amount, it's not in the right spot. It's not going to show you the right graph. But if you look at that exact same error, or that exact same mistake, you can make the exact same mistake on this bigger graph. Ooh, it's kind of hard to see there. On this bigger graph, you'll notice this guy, if I don't look at the other axis there, it's not nearly as big of a deal on the bigger graph. So the general rule that we're going to go by is we're going to make it about a half a page. Okay, you should only be able to fit 2 on there. So if you're going like this, you probably won't be able to fit 2 on there. But usually you guys have your notebook like this, so I would maybe have 1 up here and 1 down there. If you only fit 1 a page, that's fine. Okay, but I do want them to be that big, and I will mark off if they are too small. So let's go ahead and do that now. And we're going to use rulers because we want to make these lines as straight as possible. Even if you're using graphing paper, I still want you to use a ruler here to make that a super straight line. Super straight line. Okay. I'm going to get rid of this light here. I think it's causing an issue. And we make the line for the x-axis. There we go. So go ahead and make the y-x-axis for the sample graph that we're going to do in your notes. If you want to put that in your notes, that's fine. But ideally, you're using graph paper for this. So if you want to put that on a separate sheet of graph paper, that's fine. If you want to pause the video now to make sure that's done, that's cool. But I'm going to move on, assuming that you're done pausing the video. Okay, so the first thing it says that needs to go on your graph is labels. These are the things that you are measuring in a lab. Okay, there's 2 general terms that we typically use for the variables, or the things you're measuring in the lab. A variable is anything that can change. So things like time, mass, weight, volume, velocity, things I said earlier. All of those would be example of variables. In a lab, we identify the independent and dependent variables. Now, typically, in a normal lab setting, these aren't just told to you. You'd have to figure them out. So if you were doing a lab, say, measuring how much clothing people wear and what the weather is outside, which one of those is which? Well, the word independent is just like you normally hear. If you hear that a person is independent, they don't need anybody else. They stand on their own 2 feet. They don't need anything. Okay? If you hear that they're dependent, they require somebody else or something else in order to work. Variables are the same way. If it's an independent variable, it doesn't need anything else. It's going to go its own way. Dependent depends on the other. So like the example with wearing clothes and the weather, you have to ask the question, is the amount of clothing I wear dependent on the weather, or is the weather dependent on the clothing I'd wear? That last one would be great, but that doesn't make a lot of sense. I wish that I could just wear shorts and a t-shirt and it would be 70 degrees outside. The weather would depend on what clothes I wear. That's not how it works. Usually we match, we depend on what the weather is outside. So that would make weather or temperature the independent and what clothes I'm wearing the dependent. Now, in the case of this worksheet, that's not easy to see. We don't know what's being measured. So main thing you'll see here is that it tells you right down here what the independent variable is. When you go down to practice these problems, it tells you what the independent variable is in those cases as well. That says that the independent will go on the x-axis, the dependent will go on the y-axis. And in case you forgot, let's just go real quick here, come back here. the x is on the bottom, the y is over here on the vertical. So the x is the independent, and the y is going to be the dependent. Okay? So now you're not going to write these things on your graph, though. You're going to look and see what does it say is on your is the independent. So for example, we'll use the practice one right here. It says force is the independent variable. So the labels are going to be force and stretch. And what that tells me is force is independent. So force goes on the x. And stretch goes on the y. Just like that. So make sure that your graph looks like this. Pause if necessary, and then we'll keep going. All right. After labels, we have units. Units make, we almost always put units, I would say actually in this class, we're always going to have units with like every single number. Now units should be actually pretty easy because if you look right here, the units are right next to the label. So just while you're putting in force, just right next to force, make sure you have its units as well. So it should look like this. Label units, label units. Next. Okay. After units, we have title. Title your graph. Now, with this set of data we're looking at, force and stretch, you don't know the context, you don't know what the lab was, but let's give you an idea. Let's say that this lab was stretching rubber bands. Force would be how much you pull. The number going up means you pull harder. And stretch meaning just how far it stretches, how far it goes. So if you had known that ahead of time, the purpose of a title is to explain to somebody else, not yourself, not me, somebody else randomly in the hallway that you hand this to, what the graph was about. So first thing you can do is just be generally descriptive, like it says right here. Just be descriptive. So you could just say rubber band lab, and that's fine. Now, if you don't know any better, or you just want a general way of doing it, if you can't come up with anything, like it says here, here's a good rule. Write the y variable versus the x variable. Not those exactly, just what is the y variable versus what is the x variable. So it's this. There's the y variable, and there's the x. So I'm going to write at the top that mine is stretch versus force, or y versus x. You don't have to write this bottom part if you don't want, but that's the order it needs to be in. If you say force versus stretch, you're going to get a wrong answer because the order very much matters. It's always what's on the y versus what's on the x. Now, these things that I just did, especially if you have a piece of graph paper and you don't have to do the lines like I did, are going to take you maybe 30 seconds. But they are so important that they are like half the points that I am going to score on your graph. Most people, when they hear graph, they try to make the graph right away, and then they forget these pieces. I would do all of these pieces first. Label, units, title. That way you know you've knocked out half the points. Even if your shape doesn't appear here, you're going to get at least half the points. All right, next. This next part is probably the most complicated part of the process, and it is scale. This is where we differ from math. Usually in math, what you can do, because numbers are nice and clean, you can go up by just that number. If it's like 3, 6, 9, 12, 15, you just go 3, 6, 9, 12, 15. Okay? Our numbers aren't usually perfect. If you look at the data we have in this practice one, you can see here, those don't go up by a clean number, and every single one of them is a decimal. So here's the rule. Okay? The scale should go up by the same number every single time. Okay? To figure out what your scale should be, what you do is you look at the highest number and then split that up. So in this particular case, I see that the biggest number on my x is 10.4. So I want to decide how to split that up. A good rule of thumb is to go up by 1s, 2s, or 5s, or a multiple of that. 10, 20, 50, 100, 200, 500, just adding a 0 there. Okay. What you want is you want to get about five or so numbers that you're using on the bottom. okay? If you get smaller than that, like if you're just using 2 right here, like if I were to go up by 5, I'd go like 5, 10, and almost be done. That's going to make it too small again, which is a problem we talked about at the very beginning. So I'm going to choose, based on 10.4, I could see probably 2 good options here, but I think I'm going to go up by 2s. So I'm going to go up by 2, 4, 6, 8, 10, 12, and then I'm going to stop. Now, when you look at mine, you'll notice, and this will especially be true of your graph, because if you're using graphing paper, I've got a lot more lines that I could use. I got this extra line here. Why did I stop at 12? What you want to do is you want to go past the biggest number, which in this case was 10.4. And then as soon as you go past that biggest number, that's when you know to stop. I don't need to keep going because I'm not going to use those anyway. Okay. Another thing to notice here is that notice that this corner right here has the exact same space as all of the rest of them. And you'll notice I go up by 2. That's because this corner right here is always going to be the spot 0, 0. There's a reason for this. We'll talk about that a little bit later on, but this for us is always going to be 0, 0. So make sure that this first space and this first number is the same as all of the rest of them. Now, when we go over to the y-axis, we look at the y numbers. So let's see, what's the biggest number again? And it's 8.1. Because it's 8.1, I could see you using a couple different numbers for scale, but do know this, that your number on the y-axis does not need to match your number on the x. Because I got to get up to 8.4, I think I'm going to go up by 1s this time. Now, just because I go up by 1s, does that mean you have to? No. You might do something slightly different. You might have gone up by 2s, and that'll work just the same. But I'm going to do the same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to stop at 9 because my biggest number was 8.1. So I'm going past that number, and then I'm done. So right now, mine looks like this. Again, notice right down here, I've got the same space from here to here as there to there, and the same number, going up by 1, going up by 1. Okay, this is the scale, and that 0, 0 are probably the biggest things that people make mistakes on pretty early on. All right, almost done here. Next, data. Plot your points by finding the spots and the correlate between the x and the y. So let's look here. First spot's really easy. It's 0, 0. So I put a dot right here at 0, 0. Okay, I'll show you that here in just a second. But again, this is a little bit different than math. Usually, if math has really nice numbers, the dots go perfectly at those kind of intersections between the vertical and the horizontal. Here, they don't. I have 2.1 newtons and 1.2 centimeters. So I'm going to show you that here so you can see how that looks. Okay, so 2.1 newtons. Oops, it's kind of hard to see if there's a point there. 0.1 and 1.2 centimeters. You don't usually have to write this, but here's what it looks like. So 2.1 newtons. Well, first thing I do is I find 2. Since it says 2.1, though, I'm going to go just a bit further. And then for 1, okay, there's the 1. I'm going to go just a bit further. So here, it's about 2.1. So there we go. This dot goes a little bit further than 2. Oops. A little bit further than 2, and a little bit higher than 1, because it's a little bit bigger than both of those. So go ahead and put all of your dots in now. I will do the same. Okay. So I've got 4.3 and 3.3. A little bit higher than 4, a little bit higher than 3. Okay, I've got 6.2 and 4.2. I've got 8.1 and 6.1. And finally, 10.4 and 8.1. It's not going to be perfect, but when you're done, your data should look a little like this. Again, feel free to pause if necessary to get this done. The last step is what's known as the line of best fit. Okay, and that's where these shapes come in that I was talking about earlier, these 4. I'm going to sketch those out for you this time so you can see a little bit what they look like hand drawn. There's straight, it's kind of a curve down, there's a curve up, and let's call it a curve over or something like that. Okay, so let's go ahead and if you haven't yet already, go ahead and just get those 4 shapes right there in your notes next to the line of best fit part. So what you do is you look at your data and you see which one of these 4 here, does it look the most like. In our case, I would say that probably looks most like the straight line. If it's a straight line, what you're going to do is you're going to take your ruler and you're going to put it down here on the page. Do not just connect the dots, and go through about the center of all of them. Now what this means is that some of the dots it'll probably go straight through, like that one there. Some of them, like this one, it doesn't, and that's okay. We're not trying to connect the dots, we're just trying to show the general shape. That's what it's like if it's a straight line. Or you might say, what if it's not a straight line? Well, let's give you an example. Let's go put the labels on there. P, tor, that would be V, oops, milliliters. It's P versus V, because I got labels, units, and title. Let's say I'm not going to do the numbers right now because I'm trying to do this fast, but let's say my data looks like this one, okay? In which case, you look at which of the shapes it matches, and I would say it probably matches closest to this one. Since it is not a straight line, what we're going to do is we're just going to take a pen and do the same sort of thing. We're going to draw that general shape through. And again, some of the dots are going to be right on there. Some of them are going to be a little bit lower. Some are going to be the side. That's okay, as long as it comes through about the center of all of them. That's how you draw the line of best fit. If you have any other questions, please let me know. Feel free to shoot me an email. Please feel free to redo this video. We'll probably quiz on this in 2-3 days, something like that. But yeah, now you should be good to work on the graphing worksheet. Thanks, guys.